Just in previous lecture, we have already learned the concept of the two types of hierarchical clustering techniques. The one is agglomerative clustering and another one is divisive clustering technique. Now let's try to understand the agglomerative clustering technique step by step. So in first step that we have to do we have to compute the proximity matrix. We have to compute the proximity matrix. That's thing we have to do in first step. Okay. Now the question is how we will compute this proximity matrix. How we will compute it. How we will compute it. We will see. We will see. Just now, first write the step. Okay. Now after writing the step, we will see how to compute the eighth step. Okay. First write the step. What we have to do first. Now after compute the proximity matrix, in next step we have consider in initial stage we have to consider each point be our cluster. That thing already we have seen in our previous lecture. So in the next stage, in the stage 2, in the step 2, let each data point be a cluster, be a single cluster. These things we have to take. Okay. Now after the initial stage, we have to make some loop. So what is the loop? The third step, we have to make some loop. We have to the loop is loop like this. Repeat. We have to repeat. For what? We have to repeat. First thing that we have to make, we have to merge the two closest cluster. Means this is the loop that we are interested to make. This is the loop. Okay. Means iterations. It will be better if we use this word iterations. This is the simple iterations. So first iterations that we have to make, we have to merge the two closest cluster. We will see these things. We will understand these things through a picture. Now first write the algorithm. Write this algorithm first. Okay. Now in the first iterations, in each iterations, we will merge the two closest cluster. We will merge this. Okay, two closest clusters. We call A. In the second step of the edge iterations, after merging the two closest cluster, we have to update the proximity matrix that we will calculate at the beginning of our algorithm. Okay, we have to update it. We have to update the proximity matrix. Okay, that's things we have to repeat. In up to which time we have to repeat this thing? We have to repeat until only a single cluster remains. Means we have to make these iterations until we don't get a single cluster. We have to make until only a single cluster remains. Okay, we have to doing this job. So these are these three steps. We have to maintain these three steps on the agglomerative clustering. Okay, now let's try to understand how to compute this proximity. This is the main key operations to compute the two key operations to compute the proximity matrix is the means distance between the two clusters. Okay, means the simple, we have to find the distance between two clusters. That's the main key idea between to compute the proximity. Okay, the idea is different approaches to defining the distance between two clusters that make our proximity matrix. Okay, the main key idea behind it is so distance or similarity between two clusters. Between two different clusters. We have to make these things. Now let's try to understand through an example. Okay, suppose let's take we have some kind of points, such points like, suppose let's take we have 5 points. Let we have 5 data points. Let these are the P1, P2, P3, P4, P5. These 5 data point we have in our data set. Let's take now in initial stage, suppose let these are the these 5 data points. These are the P1, P2, P3, P4, P5. These data point we have in initial stage. In the stage 2 that we consider is data point is be a single cluster. So that means it is a single cluster, it is a single cluster, it is a single cluster, as well it is, and also it is a single cluster. In initial stage we have initialized this as a single cluster. So now using these things, using treated this each point as a cluster, we have to make the proximity matrix like that. This one, P1 is P2, P3, P4, P5. Similarly for a row we have P4, P5. This 5 column and 5 rows. If you just visualize these things, our diagonal elements is the P1 cross P1. So the distance between the diagonal elements is totally 0. Distance of similarity 0, 0, 0, 0. As well here is this diagonal element is a of this matrix. Now there have some values between, suppose let's take we have considered here P2 and P3, P2 and corresponding P3. Suppose let this value we have to take, we will take here. Okay, this value P2 and P3 means here this value somewhere here, taken the different color somewhere here. This value means P2 P3 means somewhere here, because it is a symmetric matrix. Symmetric means the upper matrix, this side and this side has the same value. Okay, this is called the symmetric matrix. these two value are the same, P2, P3 and this value. Suppose let's take based on our similarity or distance, we will make this matrix. If we make this matrix based on the similarity value, then we will choose what will be the maximum similarity. What will be the maximum? If we make this matrix as a similarity value, we will choose, just write this thing. If we use similarity concept, then we will have to find what will be the maximum value between the two clusters. This single point is now as a cluster point. What will be the maximum one? Now we will choose the max value. Okay. If we use the concept of distance concept, if we use the distance concept, then we will use what will be the minimum distance between each cluster. We will use the minimum value. Okay, we will use the minimum. Suppose let's take, we will use here the similarity. Okay, so based on the, suppose let's take, we will use the distance. Now the concept of the distance, we will choose what is the minimum value, minimum distance between two. If we use the similarity, then we will, what will be the maximum similarity. What is the maximum similarity? Because you have seen this, the relations between the similarity and the maximum is proportional to each other. It's inverse proportional to each other. Sorry for that. Similarity are inversely proportional to the distance value. Okay, we will see these things. We will already we have see these things because of these reasons. Suppose let's take, suppose we are using the similarity concept and we choose that this is the maximum similar value. These value are the maximum similar value. These two, P2 and P3, these value is the similar one. Now from here we can make these P2 and P3 are the most similar one. Now we make this is a single cluster. Okay, this we will make this is a single cluster, and these are the remain single cluster. This is the single. This is the single. Okay. Suppose let's take. These are the. So let's take. This is the max value. Among all the value. Then we make this is, and now this, suppose let's take this cluster, we name this cluster as a P2 union P3. Let's take, we rename this cluster as P2 P3. Now in next step, the cluster, the proximity matrix that we have, now in next step, proximity matrix that we have will be now this type. So here, instead of using P2 and P3 in different point, we will use as a single point. First point will be P1, second point will be P2 union P3. Third point will be P4, fourth point will be P5. Similarly here also P1, P2 union P3, P4, P5. This 4. Now our will there have 4 column and 4 rows, and now we'll treat P2 and P3 as a single element. Okay, now similarly here also, similarly here the diagonal element will be 0, the diagonal element will be 0. Okay, the diagonal element will be 0. But now the questions that comes into our mind, the questions how to find this, value. Means value means I'm talking about how to now compute the proximity value between, this is a single cluster now, this is a single cluster, how we'll find the proximity value between these two. Means now proximity value, how to compute the proximity value between this whole cluster to this cluster. How will compute? What will be the now proximity value? What will be the now proximity for here? What will be the proximity for this forecast? Okay, now what is this value? So here, what will be this value? Because the rest of the one we know, it is known, it is known, it is known. We have already known these things. Now the questions that first, how will compute P1, P2, this one, this one, this one as well for this row, and for this column. Similarly for this column, P1, this one, this one, this one. I think it is known. I think this simple, this row and this column, this row and this column. What will be this value? This is the big question. If we calculated it, then again we will repeat the same thing, and again we will build the proximity matrix. Again we will repeat the same thing. Again we will repeat the proximity matrix, and based on this proximity value, we will make our cluster. But the questions, how we will make this? How we will make this? Okay, so that thing we will see in our next video. I think from this video you will understand how we will compute this thing. So let's try to understand it through this another example. Let's try to understand through this another example. To another example, if you faced some problem, suppose let's take the point that we have in initially have, suppose let's take this type of point. There have 2 points, there have some points, there have some points, there have some points, there have some points. Let's try to understand in more deeply. Okay, suppose let's take, these are the data set, whole data set. Initially h point, how much point we have? 1 2 3 4 5 6 12, total 12 point we have here. So in initially the cluster number of clusters here, how much? 12 cluster we have. P1, P2, P3, so rename it 1 2 1 2 3 4 5 6 7 8 9 10 11 12. This 12 point we have. Instead of using P1 again, it just write it 1 2 and 3 4 5 6 4 5 6 7 8 9 10 11 12. This 12 point we have. This 12 point we have. Let's take. Now first we have to make the proximity matrix. How we'll make? By simple using this formula, P1, just instead of using P1 again and again, 2 3 up to 12. So 1 2, this value will be up to 12. Okay, we can use these things, and the diagonal element will be must be 0. This diagonal element must be 0 0 0 0, all the diagonal elements. The main questions is, in initially we will use it easily, we will calculate it, the distance or similarity between each point. In initially it is not a matter. Now suppose let's take, initially we will calculate some distances, individual points we will calculate some distances, and main based on the distances, mean just if you can't taking the distances, then using the mean value we will find that this will make a one cluster. Suppose let's take, we will find that this will make a single cluster. But let's take this will make a cluster, this will make a cluster, this will make a cluster. Let's take this will make a cluster, this will a single cluster. Let's take this is a cluster C1, C2, C3, C4, C5. But let's take using these two point a cluster will make a single cluster. 3 and 4 using this 3 and 4, just I am drawing the dendrogram, will make a single cluster here. 5, 6, we will make a cluster here. Means I am drawing here the dendrogram picture, okay, for your better understanding. And similarly for using this cluster, means 7, 8, 9 will make a single cluster here, will make this cluster. Similarly for here also. Now this is a single. Now from 12 point, now we will make here 5 cluster. Okay. Now somehow suppose let's take initially we will calculate this value based on the distances. Based on the distances, we'll calculate this value based on the distance. Okay. Now after this step, we will make the 5 cluster. Now we have to update the proximity matrix value. Now our clusters are look like this. Now this cluster. Now for this 5 cluster, the now proximity matrix now here it will be C1, C2, C3, C4, C5. These are the proximity. This is the cluster 1 for cluster 2, for cluster 3, for cluster 4, for cluster 5. Because now the questions that how we'll compute it. Now the questions that's come into our mind, how we'll compute it, these things. C1, C2. Okay. Now the questions that come into our mind, how to compute it, this value. C1 to C means this value. Now this value will be 0. That's obvious. There have no any problem. There have no any problem. Okay. Suppose let's take, now we have to come in this step. Now we have to find the distances between the edge clusters. We have to find the distances between edge clusters. Now we have to calculate a distance between the edge clusters. These distances we have to compute it. We have to compute it. Now how we will compute these distances of similarity? Now the question is that. Now the big question is how we compute these similarity value. This is the big questions. How will compute it? How will compute it, this thing? Okay, that's the first question. Now the second question that. By example, using the, if we compute the distances or similarity, then based on the distance or similarity, we merge these two clusters. Now the questions, how we'll merge these things? The second question that's come into our mind. After computing this, how we will merge this cluster? How we will merge this cluster? That's the second question. We'll see these things in the next video. How to compute the distances or similarity between two different clusters, and after computing this, how we'll merge this point. We'll see these things in the next discussions. I think from these discussions you got the idea how to compute the agglomerative clustering. It's the very simple idea. Just these three steps we have to maintain. The first main the computational part is here to calculate the proximity matrix. I think for initial points computed the proximity values, it's trivial, you can easily find. But after initial stage we will come into our iterations to merge and to find the proximity value between the each clusters. This is the most challenging in this clustering. We'll see these things. There have some mathematicals, there are various kind of techniques. We'll see these things step by step. These things we'll see in next video.